So this is a lesson for the electrical engineer practice. So we are talking about the hand tools. The hand tools include the hammer. This is what the feature of the engineer hammer. So the hammer here here is a handle wrench. Here is a plain hammer. So in this case, this is we call as a bobbin hammer. When we are using a hammer, important is never use a hammer with the loose head, because when the head is loose, it will be coming out from the handle and can hit someone. Never strike the hard metal. If you use as a hammer, do not strike the hard metal, because it can also damage the head of the hammer. So also we have to wear the appropriate safety glove and the safety glove and the safety glass, because of the hammer for the impact. This impact can hurt your hand. This is why you have to absorb any impact. So we have to wear the to reduce the impact. You have to wear the safety glove. So this is a claw hammer. Claw hammer is the function of claw is to remove the nail. So that especially the carpenters are using the claw hammer to remove the nail. So here you got as a hammer head. So if you use as a soft hammer, because sometimes you want to work on the copper or the brass, in this case we are using a soft hammer. Here is we can talk about the flat blade and also fillet head. Flat blade and also fillet heads are kind of the hammer. This is for the screwdriver. So screwdriver, you got the flat blade and also the fillet head. Flat blade and the fillet heads are the kind of the screwdriver. The screwdrivers are widely utilized in the electrical engineering work, especially the to remove the screw or to tighten the screw. So flat is we can use for the flat screw, and fillet head is the star. So for the star screw head, we have to utilize the fillet head screw to remove it. And sometimes we also need to utilize the spanner. The spanner functions spanners are being utilized to tighten the nut and tighten the bow and not tighten it. We are using the spanner. So there are two kinds of the spanner: open spanner and the ring spanner. So open spanner, this is the figure of the open spanner. This is the ring spanner. So this is the open, this is the ring. Some spanner got the open and the ring both, so that you can use both sides to fix them and remove the knot. So this is the function of the spanner. So here is we can use a tie. Those are the figure of you are using a tape. So this is tape and tie diagram here. Then we also utilize the pipe wrench. The pipe wrench function is to fix the pipe. And also we are using this plier. The plier got the two plier. First one is a combination plier. The next one is a diagonal cutter. So diagonal cutter is not only utilize to cut any wire or anything. You can use as a diagonal cutter to cut it. And also combination plier is to also strip off the insulation from the wire. We are also using the combination plier. And also the electrician pliers all are insulated, because sometimes we have to work on the electrical power line. In this case, insulation is a very important aspect. And also the multi-grip pliers this include the wrench and the plier. The long nose pliers are also utilized. This is the long nose plier to handle the small screw and the electronics pieces. We are using the long nose plier. So those are the application of the hand tools. I have already talked about the plier, screwdriver, hammer, and also in this case you have to do this tutorial. State the thread angle of the isometric thread. So this is a symmetric V shape, and V has an angle 60 degree. Thread there is a 0.14 into multiplied by pitch. Also, we also write the operation steps for the drilling and inserting the angle. So in this case, firstly you have to drill the hole to the side and So embedded are required and insert the anchor into the to fix preacher and hammer the screw into the anchor body to expand. To remove, in this case, we have to utilize the press the Phillips screwdriver firmly into screw head and there's a turn counter crosswise. So this is the how to utilize the drilling and inserting the anchor. Here is this diagram is we can use as a pipe wrench. The pipe wrench if you are using the any screw tapping. So here is if you want to make the thread on the pipe. So thread is hold by the holder, and then we use a tape and die, and then we make the thread, making the thread. So after that, we talking about the joining techniques. So we have to utilize the fastening devices. In this case, we use the thread, bolt, and nuts to fasten the devices. So there we also utilize here is a bolt nut here. We use as a metal thread. So here we use the washer. Here is bolt and nut. So this is assembly of the bolt nut and the washers assembly. Here is a metal thread. We call the cat screw and also set screw. Here is a nut. So nut is this is we call it first one is a lock nut. Second one is the standard nut. So if you want to lock the something, we have to utilize the two nuts together. Lock nut function is to adjust the position of the nut, and standard nut is to tighten the nut. So also in the industry, we also utilize the set-tapping screw. Set-tapping screws are the here is gimlet point. This is to fix the any screw on the plaster bolt, and here is flathead and also mushroom head. They got the counter sand and also the bagger head. So they are kind of the screw, flathead, mushroom head, counter sand, and the bagger heads are types of the set-tapping screw. Also, we are using the porter bed. Porter bed is we use the porter bed gun to make the riveting on the wall. So we also utilize a nylon porter bed. Here is we use a riveting gun. Riveting gun, in this case, we put the rivet into a riveting gun, and then we have to do the lever. We press the lever, and then we can fix the any rivet on the wall. So this is how to utilize a riveting gun. Here is a lazy dome, and this is the best screw and bolt and nut are there for temporary fixing. But if you want to fix it permanently, we either use a riveting, or we also utilize a welding. Welding function is a fusing the method. So we have to fuse the method where the metals are being joined together. So in this case, one method is making the fusing. So this one method is liquefy, so make the dissolve the metal, and then we have to utilize and bind them together. So in this case, this is the welding method. So welding methods are that there are two kinds of the welding. For the small material, we have to utilize the soldering method. So solder is here you got the electrode, here is electrode gun. So that we heat the electrode by the soldering iron. So the solder it will be the melt down, and then it will go in onto the wall surface. So this is the soldering. And in this case, we have to utilize as a deposit the metal on the welded metal. And here we use a welding. Welding method is we have to utilize a welding machine. Welding main function is we grid the electrode, and the high current is flow into the electrode, so that the electrode will melt down because the high current, and then the electrode materials will be melt down and they fall into the wall piece. So this is we have to utilize a welding transformer and electrode together. So the function is the transformer function. The transformer provides the high electrical current large enough to make the electric arc between the flux of the electrode and then the wall temperature. So wall temperature is 6,000 degrees centigrade. Soldering is a process of the joining the metal together by means of the alloy melted into the joint after the application at the suitable flux. So in this case, we have to utilize the appropriate suitable flux is utilized, and also we melt down the solder, and then the solder will fill the wall pieces. So this is one similar soldering item. So here is a gas welding procedure. Gas welding procedure, we using the acetylene bottle and oxygen bottle together. So those are pipelines are connected to the nozzle, so that the combination of oxygen and acetylene are then burned by using the fire, and then this is a nozzle head. If there's a fire is coming out, though fire will heat the electrode, and then we can do the welding. So this is for the acetylene welding system. Here is a diagram of the pipe grade, so we can fit the pipe grade for the anti-tapping. And here is the student is doing the tapping on the making the thread on the pipe. So this is for the we handle the pipe by using the pipe wrench, and we are also turning and we are making the thread. So this is the up to this stage we are talking about the basic handle regarding the basic handle and regarding the basic workshop function. Here is electrical basic wiring system. Wiring system, this is for the LAN, and also this is for the switch. So this is TBS wire. So this is red is a active wire, black is a neutral wire, and the green is the earth wire. So they are connection of the electric circuits and the lighting circuit. Then we also utilize portable power tools. The power tools are safety is important aspect, because before you using any power tool, you need to wear the appropriate protective equipment. So you also have to keep the work area tidy, and also be aware of the high torque rotating of the sun tool, especially the sun cutting machine, sun drilling machine. They are running at this high rotating. So rotational moment is very important. So that high rotating torque has to be aware of. Don't lay down until they have stopped the rotation. And these are handle you are utilizing any hand drill or grinder. You make sure you have to store the those equipment after that you can put on the floor. Otherwise, because of the high rotation, they will jump and it will hit the person. And also maintain your balance, especially on the ladder. Sometimes you have to climb onto the ladder and you walk on the height, walking at the height. In this case, you are drilling while we are there standing on the ladder. In this case, you have to control your body balance. Because high rotation is a threat, you will fall down. You will fall down from the ladder. So therefore, when we are walking on the ladder and you are doing the drilling by using your hand drill or power drill, you have to important to maintain your balance. And when you are drilling and guiding the workpiece, we have to securely clamp it. Before you are guiding or you have to drill something, you have to securely clamp by the vise or the anti-clamp. And otherwise, because of the high speed of drilling, the workpiece will fly out and it can hurt you. So all the electrical power tool devices are utilizing the electrical safety, electricity. Therefore, the electrical safety is important aspect. Always inspect the tool before and after utilizing. Verify the tool has been tested for the safety recently, and check the condition of the cable before you are using. Lay out the electrical cable so they are not tangled. Don't use the electrical cable when quiet. Also, you have to use a leakage protected device have to be utilized, because any leakage to the electrical tool, it can do the short circuit to you. If you use a leakage circuit, which I also important aspect, disconnect the LED before using the adjustment. So this is for the important aspect of the electrical safety. Here is a diagram of the grinding machine. So this is a hand grinder machine. So that when you are using the hand grinder, you have to wear the eye protection. Also, this is a straight grinder. Grinder got a different kind of grinder: straight grinder, angle grinder, die grinder, sander. The function is to smooth the surface to remove the undesired metal parts. So they never put the excessive pressure on the wheel while you are grinding, because of it can damage the grinding wheel. Never grind a soft material. Here is a diagram of the drilling machine. So that we have to check the drilling machine. You have to see the choke capacity, because the choke need to hold your drill head, drilling bit, So the child must be the appropriate for your drilling bit. It's an important aspect. Here is we can utilize the circular saw. Circular saw that we have to utilize for the cutting. If you want to cut this timber cutting, we are using the circular saw. So in this case, timber cut with the circular saw should be where the supported by the illegal grinding machine. So the timber need to be the properly secured on your support, and then we have to cut the timber by using the circular saw. Here is shearing machine. So the function is cutting the and snipping, and this nigger is to cut the sheet metal. Those are function of your hand tools and the power tool. So hand tool and power tools are especially utilized for the electrical workshop to cut the sheet metal, to cut the material. So here is diagram of the your electrical workshop. So this is electrical switch and also the electricity ceiling rows. They are diagram connection diagram. So those people are doing the electrical work. And also we also utilize the measuring equipment. So measuring equipments are widely utilized in the electrical workshop. So we use a caliper, marking. So caliper, they are function as the marking up, and this is for the. And also we are utilizing the punch. So in this case, punching you have to marking, or you are using a scriber are making a mark, and here is surface gauge. In the meantime, you also need to do the sometimes cutting, so you are using a hacksaw. This is hacksaw blade, so we use the TBI. And we also utilize the chisel. The chisel is to cut the sheet metal by using a chisel. And also we are using a file. Filing machine, you have to cut the metal by filing, or we are smoothing the metal pieces by filing. And so here we use the chisel head. The chisel head function, those are the chisel function to making the cutting. So this is for the diagram of the file. File also we are using we use it together. So we use a chisel. So chisel angle. So this is for the A is we call the break angle. B is a cutting angle, and C is a clearance angle. When you are using this chisel, there should be the angle like this. So A is a break angle, and B is a cutting angle, C is a clearance angle. So if you put the wrong angle, it will not be affected. So after that, you have to do the workpiece. So we have to cut the workpiece, and we have to use the chisel and the cutter. You have to cut the workpiece. Then you have to punch the hole. Punch the hole by using the chisels and the hammer. So we are talking about the consumer made and the maximum demand. Now we're talking about the electrical wiring system. So consumer made here is electric bulb, and the wire is connected to the main switch. So this is we call the consumer made. Consumer made are the conductors between the point of the supply. So this is the point of supply. The main switch board. So this is the point of supply. This is the main switch board. So the wire which connect the main switch board and the point of supply is we call it the consumer made. Consumer made is a part of the electrical installation. So this is for the overhead conductor. Overhead conductor point of supply. The overhead conductor go to the main switch board. Here is an underground. So from the point of supply is a wire go to the underground, and then here is point of supply, and then we connect it to the main switch board. So this is we call the consumer main. So both of the overhead and the underground system, we use a consumer main. So there are type of the bearings. Now type of bearings are depending on there are different types of bearings. There are timber bearing, steel frame bearing, rib veneer, PVC, cavity, double bricks, steel, and also a concrete reinforced concrete bearing. So there are different kind of building. When we are install a building, yeah, installation condition. The category A is a insulated and a sheeted cable on a cable tray. So we run the cable on the insulated and a sheeted cable on the cable tray. Category B is a MIS cable. So minorly insulated metal sheeted cable. So minorly insulated and a metal sheeted cable, they are the on the cable tray. So this is for the cables are construction. So this is the category size A cable. It's an insulated sheeted cable. We run on the cable tray. So this is cable tray. The cables are run on the cable tray. Category B cable is a MIS cable. This is a minor insulated metal sheeted cable. They are fixed directly to the concrete wall. So this is the categories of B cable. The next one will be this is for the different kind of cable we connected. So category C is a insulated and a sheeted cable. They are buried direct in the galvanized underground. So this is category C cable. And also this is the category C cable. So this is for the arrangement of arrangement of this is a point of supply. Now this is we call this a main switch. From the main switch connected to the sub main and connected to the sub distribution valve. So from the sub distribution valve, the wire connected to the final sub circuit. Final circuit connected to the load. So this is for point of supply, consumer main, and the wire go to the main switch. From the main switch, there will be the final sub distribution. So the wire between the main switch and the sub distribution is we call the sub main. Then from the sub main, we connected to the finest load. So load is we call the finest sub circuit. So load can be there's a lighting load or the power load, socket outlet load, hot water load, electric water. So they are different kind of load. All the electrical loads are beings are used at the same time. Well, because of not all the electrical loads are being utilized at the same time. They got the time difference between the one load and another load. This is we call the diversity. Diversity is not all the electrical loads are using at the same time. They got a different time. So the one load is, for example, one load is the mornings 7 to 8 a.m. We connect the switch, but some load is from 8 to 9 a.m. So this is why all the load got a difference of time usage of time. So this is we got the diversity. So based on the diversity, this factor is a diversity factor. Diversity factor need to be calculated. So that we use the AS3000 rule, table C1, C2, C3. They are the diversity and then also maximum demand calculation. So we had to calculate the maximum demand by applying the AS3000 table C1, C2, C3. So table C1 for the single and the multi-phase electrical installation, multiple electrical installation, and the C2 is a hospital and the business installation. So there will be the residential and also the facility, school, and also C3 is an energy estimating of volt ampere per meter square meter. So they are the kind of the electrical installation. So we have to utilize the maximum demand calculation. So in this case, we are using the AS3000 rule. AS3000 rule has to be utilized. So this is I open the page for the AS3000 rule. AS3000. So this is AS3000 rule. So AS3000, table C1, C2, 3 have to be utilized. Then we refer the AS3000 rule and then we solve the one problem. Okay, this problem, we solved this problem. Determine the maximum demand of the single domestic electrical installation supply at the single phase. So it included 24 lighting point and 10 meter lighting track and a 4 number of the 10 ampere single socket outlet, 8 number of the 10 ampere double socket outlet, 1 number of 50 watt exhaust fan, 1 number of 1000 watt switch heater, 1 number of the 15 ampere socket outlet, 1 number of 10 kilowatt range, and 1 number of 4.8 kilowatt water heater, 1 number of 3 kilowatts are tennis scope lighting. So those are the kind of the electrical loads are provided. So based on the those electrical load, we need to calculate the maximum demand. So the maximum demand calculation, we had to utilize the AS3000. So this is AS3000 table C1. Table C1 is located at the phase 464. This is the table C1. So firstly, we have to see this which loads are utilized. So this is for the consumer installation. So this consumer installation is single domestic electrical installation. So the tables are C1. You look at which one is the tables are C1. This is the table C1. So here is column 2 is a single domestic electrical installation. Column 2, 3, 4 are block raven unit. 2 to 5, 5 to 20, 21 or more to a block raven. So in this case, this problem is given the single domestic electrical installation. Therefore, that we have to refer the column 2. So column 2, you have to refer it. And then you have to see the how many are light point. So light points are here. Firstly, we call the 24 lighting point. 24 lighting point is load group B1. You see the 24 lighting point. This is the load group B1. Socket outlet. So this is for the lighting asset. So load groups are A1. Lighting asset. So in this case of 1 to 20 point, you have to take the 3 ampere. So additional every 20 point increase, you have to add the 2 ampere. So this is for this rule. Because all the 24 lighting points at this rule, we have to refer that this load group A1. So their rule is 1 to 20 point, we take the 3 ampere. So additional additional every 20 point, you have to add the 2 ampere. So that this problem is given the 24 lighting point. 24 lighting, because of 24 lighting point, first 20 point, we take the 3 ampere. So additional 4 point. Additional 4 point within the 20, so you got the 2, you add the 2 ampere. So this is the total current will be the lighting point is so here the calculation 24 point. So this is the lighting point. Another thing is also we find the 10 meters lighting track. So it is also given the 10 meters lighting track. So what is a lighting track? Lighting track is you see the lighting track here. Lighting track lighting track is a load group G1. No, this is the you see the lighting track. The group we look at here. So 10 ampere lighting track here, load groups are A1. So below 4 and 6, so you see the 4 and 6 here. Lighting track is a 2 points per meter of track. Because all this load group A1. low group A1 is, you can see the below 4 and 6. Below 4 and 6 is the full node 4. Full node 4 is a lightning thread. And 6 is a calculation incandescent lamp. So the also the lightning thread is a every 1 meter is equivalent to the 2 point. So this is the lightning thread calculation. So this problem, lightning thread is 10 meter lightning thread. So therefore the 10 meter multiplied with 2. So there will be 20 point. So this is the lightning thread. In the meantime, we also saw this problem. You can see the exhaust fan, 50 watt exhaust fan. This is also the group A1. So that when you look at the group A1 is also we can see about the node. This node is 4 and 6. 4 and 6 is this is the 4 and 6. So this is 4 is a lightning thread. What about the full node 6? The full node 6 is here. Full node 6 is a incandescent lamp up to 60 watt. So any incandescent lamp, we can take the 60 watt or the fluorescent lamp, and also others are power. Other power, so less than the 60 watt. So that any lamp holder, any power less than the 60 watt, we can also consider as a also the lighting point. So that this problem is given the 50 watt exhaust fan. So this 50 watt exhaust fan is their power is also less than the 60 watt. So this 50 watt exhaust fan also counted as regarded as a light point. So that what are the light point now? They are the 24 lighting point, also the 10 meter lighting thread, also the 50 watts exhaust fan. So there are 3 kinds of the light point. One is a 24 lighting point, now it's a 10 meter lighting thread, and also 50 watt exhaust fan, equivalent light point. So therefore the 24 lighting point is we can count the 24 number of lighting point, and 10 meter lighting point thread is every 1 meter equivalent to 2 points, so 2 multiplied 10, and also the exhaust fan is a 50 watt. So this is also we can regard as a light. So they are point are how many? 24 plus 2 multiplied 10 plus 1, so there will be 45. So they are 45 points. So therefore, because of the 45 points, we have to count the low group A1. So low group A1 is there will be there's how many points. So every 20 points you have to count the 3 ampere. And so that 45 is equivalent to the 20 plus 5. So the first 20 point, 3 ampere. Second 20 point, 2 ampere. And then additional 5 point also we call it, we add the 3 ampere, 2 ampere. So therefore the how many current, how much current there will be? No. First 20 point is a 3 ampere. Second 20 point is a 3 ampere. And final 1 point is a 1. So this is a 45 ampere. So this is the way we calculate it. So maximum demand is 45 ampere. Okay, this is the things how we calculate the maximum demand. The second one is that we also the 10 ampere socket outlet. 10 ampere single socket outlet. Now 8 number 10 ampere double socket outlet. So the 9 number 10 ampere socket outlet we count the 9. 8 ampere 10 ampere double socket outlet, so 8 multiplied 2. So there will be 16. So this is there will be the 25 socket outlet. So how to calculate the socket outlet? Socket outlet is low group P1. First 20 point we take the 10 ampere. So another additional 20 point we take this 5 ampere. So this is the low group P1. Low group B1, this is the low group B1 room here. First 20 point, you take the 10 ampere. Another additional 20 point, you have to take the 5 ampere. So therefore, the total socket outlet is 25. So the first 25 is we take this first 20 point, we take the 10 ampere. Additional 5 point, we got the 5 ampere. So there we get 15 ampere. In the meantime, you also see the 1 about 1000 watts of straight heater. 1 about 1000 watts straight heater is low group B, no? Low group C. So this is straight heater. So straight heater, so this is for the straight heater. So this will be the street heater is similar to the instantaneous water heater. So instantaneous water heater is we can see the rule of the instantaneous water heater. So instantaneous water heater here. This is a 33.3% of the connected load because the load group is E. Instantaneous water heater is similar to street heater. This is the load group E. So we take the 33.3% of the connected load. So 33.3% of the connected load we calculate that. So the 1000 watts, so 1000 multiplied 33.3 multiplied 0.333. So you got the watt. So this is divided by the current voltage are 240. So you got the 1.387 ampere. So this is for the 1000 watts of street heater we calculated. In the meantime, we also got the one number of 15 ampere socket outlet. So log 15 ampere socket outlet is a load group P2. You see the load group P2 here, socket outlet. So in this case, any socket outlet, any saturation, we have to take the 10 ampere. So therefore, for the 15 ampere socket outlet, we take the 10 ampere. Another thing is 10 kilowatts electric range. 10 kilowatt electric range is load group C. So this is the load group C. 10 kilowatt electric range load group C. So electric range is we have to take the 50% of the connected load. So 50% of the connected load here we calculated. 50% of connected load is 10 kilowatt range. So this is the multiply 50%. So the 10 multiplied 10 power 3 multiplied with 0.5 and divided by 2 for D. Then we calculate the current. So this is the way we calculate the electric range current. So electric range current is 20.8 ampere. Then you also see the 4.8 kilowatts water heater. So here we also given the 4.8 kilowatts water heater. One about 4.8 kilowatt water heater. So this is a load group F. So load group F here, water heater. Water heater, you have to take the full current. So the 4.8 kilowatt, we take the full current. 4.8 multiplied 10 power 3. So this is what? And divided by 240, you got the current is 20 ampere. So this load group is, the current is a draw is 20 ampere. And finally, it also given the 3 kilowatt standard scope lighting. 3 kilowatt standard scope lighting is a load group A2 because load group A2 is here. This is the outdoor lighting. Outdoor lighting. So exceeding 1000 watt. So in this case, we have to take the 75% of the connected load. So 75% of connected load is load groups are A2 got this standard scope lighting. So that will be the 3 kilowatt, 3 multiplied 1000, 75% of multiplied 0.75. So you got the power divided by 240 volt, you got a 9.4 ampere. So then you have to add everything. So that will be the, from here, all the lighting point is a 7 ampere. And also the socket outlet, 10 ampere socket light, 15 ampere. Instantaneous water heater, 1.387, 15 ampere socket outlet, 10 ampere. And electric range at 20.8 ampere. And 4.8 kilowatts of water heater, 20 ampere. And also tennis scope lighting, 9.4. You add everything, you got that 83.5. So this is the way we calculate the maximum demand. So this is the way we calculate the maximum demand. So this is for the electrical engineer practice. We calculate the maximum demand calculation. Then we also do this electrical engineer trade practice. So electrical engineer trade practice 1. So trade practice 1. So there will be the page number 94. So electrical engineer trade practice one is we talking about the powers generation and the pollution. In Australia, all the coal-firing power plants are being utilized. So the coals are the 你那个这种你哈他妈干贵的啦，coal are producing the free，那这些东西都没有，你一边啊咪对你啦，但係呢個對你，你講你聽到你話冇？哦，就翻窿窿，你第一窿窿，點解第一窿窿嘅？窿窿嗰啲第一就另外窿啊，你一邊啊都啊啦。多刷啦呗。多刷窿啊，你話你對面咪嚟到嘅？呢個係。Co-firing power plants we are utilizing so that we heat the coal. Now we got this heat, the heats are provided to the furnace. So that the furnace are producing the carbon dioxide. Those carbon dioxide we producing those carbon dioxide are polluting the environment. So those carbon dioxide electric furnace are that we are heating the boiler. The boiler produce the steam. So those steams are the driving the steam turbine. So those steam turbines are the rotating. Those rotations are the rotate the generator and we produce the output power. So that because of the coal-firing power plant, the carbon dioxide are being produced. So those carbon dioxides are the polluting the environment. Therefore, we have to reduce the carbon dioxide. So we are using the solar electrical system. So sun energy fall onto the solar panel. So those solar panels are produce the electricity. Those electricity are we supply to the inverter and the AC grid we being supplied. So that in this case, this electricity also we supply to the battery. So that this is for the renewable energy system. So we use a wind turbine, we use a geothermal energy, also the energy through system tidal way. By this way, we can reduce the pollution caused by the coal-firing power plant. So that because of that, in this case, we had to reduce the greenhouse gas emission. Greenhouse gas emission is we have to use a lesser electrical power. Also, we have to use a less heat and air conditioning. We have to use a energy efficient power. We also use also the less hot water system and use a offset. So those are the strategy to reduce the greenhouse gas emission. So also we are using the cogeneration and the combined heat and power. Coal is a fire the furnace, so that the furnace produce the boiler, and the produce the boiler is also produce the heat. Those heats are also driving the steam turbine connected to the generator, and then we produce the electricity. In the meantime, the outputs are steam turbine output we use as the steam. That steam is we pass it through the heat exchanger. This heat exchanger after that you connected to the cooling tower. The cooling tower we are the converted steam into the water, and the water we put into the tank, and then water pumps are also rotating, and then we feed the water back to the boiler. So that this heat exchanger system, we also heat the water. So this heat water also we can utilize a hot water supply. So this is the combined heat and power system. So combined heat and power system is cogeneration system. So we also utilizing the combined heat and power system. By this way, we can reduce power energies efficiency. We can improve the power energies efficiency. We also use the reduction of the energy use and greenhouse gas emission. So we have to design the energy efficient building system. Also, we use the natural light. Natural light is a descent to the enter to the building. So that instead of we are using the electricity, we use a natural light system. By this way, we are using the electrification, especially the big supermarket system. We got a skylight. Though from the skylight, the sun is fall into the skylight, and then the illumination is provided to the building. So this is the way we are using the natural light system. In this case, sometimes we also need to orient the building to the wind direction. So the wind are directly enter to the building. Therefore, the air circulation can be provided naturally. So by this way, we have to reduce the requirement of the air conditioner. So there are energy efficiency, energy reduction principle, promoting the increasing the use of the nature's energy system. So we have to utilize the appropriate materials and installation to protect the heat flow. Also, we have to utilize the energy efficient equipment. We have to implement the energy saving program, and by reducing the energy wages, we also utilize the electricity to reduce the greenhouse gas. So we also have to find out the recycling system. Recycling is we use the appropriate recycling system. So we use the recyclable material, and we have to reduce the pollution. So the type of the recycling materials are the glass, metal, organic, paper, plastic, and textile. So those are important aspects of the energy efficient design system. So we also utilize the recycling. So they are the appropriate recycling. So we have to apply those strategy to reduce the greenhouse gas emission. So use a ceiling insulation system because of the most of the heat are coming through the ceiling. Therefore, by using the ceiling insulation system, we can protect the heat. So if you protect the heat transfer, we can reduce the requirement for the air conditioner, and we don't need to switch on the electrical power supply. By this way, we can reduce the energy. Also, the opening up the north facing with the large window because of the in Australia, most of the sun energy are coming to the building through from the north. So we have to use a north building. So large windows are we provided. So by this way, we can get the nature's energy. Placing the shade tree adjacent to the house to reduce the heat energy. Installation of the solar water heater system, and also the installation of the solar electrical system, installation of the reflectors guarding system. By this way, you have to reduce the electrical power. And try to use the green power, install the visors to reduce the water, installation of the water tank, installation of the nature gas heater, installation of the cells closing door. Those are important aspects to reduce the greenhouse gas. Then you have to answer the two questions. Those questions are the energy, the greenhouse gas reduction strategies question. Then we saw the sum problem. We have to determine the requires circuit breaker to protect this circuit. So in this case, 9 double socket outlet. So the 9 double socket outlet with 9 multiplied by 2. So this is the 18 socket outlet. So what is the power? First socket outlet is 1000 watt. And another socket outlet is 100 watt multiplied the remaining socket outlet. This is the rule. So therefore we have to find out the table C2 of the AS3000. So this is the AS3000 rule, table C2. Table C2 AS3000 rule. So total socket outlet is a total power. So total power is table C2. We are using this AS3000. So this is a rule here. So socket outlet not exceeding 10 ampere. So the 1000 watt for the four socket outlet and 400 watt for the each additional socket outlet. So this is the rule we have to utilize. So that electrical installation, where is that electrical installation? So this will be the you are required to install a 9 number. What you are required to install a 9 device 10 ampere socket outlet. So this is for the factory. So this is a factory system utilizing. So in this case, this is a socket outlet application. No, this is be like you are a South African guy do it. This is not South African. But doing not the money I mean, what you dying on Lama guy will be there. That one in Amle when I will be there. Bye bye, we're going to deal with a lot of it. Some like then one of the socket outlets, so this is for the first socket outlet, we have to take the one of the watt and the additional of 400 watt for the each additional socket outlet. So this is the rule is given. So this is the factory law is that we use the table C2. So this is table C2 is a first socket outlet is this is how many socket outlet? So this is 1000 watt multiplied with a 400 watt multiplied remaining socket outlet. So this is with the total socket outlet is 18. So the first thing you have to take the 1000. Additional is a 400 watt multiplied 17. So this is the way we calculate for the power. So this is the socket outlet calculation. The number B is we have to determine the required circuit breaker to protect the socket outlet. So in this case, we have to calculate the socket outlet. So in circuit breaker side, so there will be we have to find out the total to the circuit breaker. So total power 2700. So divided by 244, you got the current. And then this current, based on this current, we have to find out the to the circuit breaker. So we have to apply it table C6. So this is a protected by rating. So this is current and also the conductor side with the calculation. So there will be the 11.25 ampere. So in this case, 11.25 ampere. If we utilize it, this is the current 11.25. So there are no 11.25. So we have to utilize a 16 ampere. Then this is the cable side we calculated. So this is the way we calculate the cable side. 1.5 millimeter square is a cable side. The next one is 2.5 millimeter square 4-core e-circulator circular TPS installed enclosed in the air for the connection of 3-phase socket outlet. So in this case, we have to determine the temperature is negligible. What is the maximum size of circuit breaker? So we have to find out the table C6. Table C6 is the 20 ampere. So 20 ampere here. This is 20 ampere. The 20 ampere, then this is for that. By this way, you call it cross-sectional area of this. The wire we calculated. So that is the 255 millimeter square. So the 20 ampere. This is the way we calculated. Then you also look at this the remaining node. So we can also find out the appropriate socket outlet design. So this one is we can find out the how they determine the socket outlet maximum demand calculation. This is the way we calculate it. Then we see this as socket outlets are polarity. So lesser is This is for the active, right side neutral, bottom one is R. So active to neutral is 230 volt, active to I is 230 volt, neutral to I is 0 volt. So here is this is we call it infinity. So we measure the between the resistance between neutral and arc, there must be the infinity. So socket out the wiring diagram. So this is the we have to write the wiring diagram. Means this is for the arc link, this is neutral link. So I and neutral connection is the NVN. Here is the RCD. So so this is for the electrical current from the main switch connected to the RCD. So this is a red is connected to active and connected to the circuit breaker and go to power. And neutral is here connected to the neutral and also green is the out. So this is for the electrical power supplies are connection. So this is for the electrical main supply connection. This is for the connection of the three-phase electrical system and also measurement system. So here is a connection is this is a socket outlet. So this is circuit breaker. So link, this is neutral link. So we have to measure the resistance between this and this one. You can connect the 10 ohm. Here this one you can connect the 5 ohm. Then you have to measure the ohm meter. So by this way you can measure the polarity. So this is a polarity measurement connection diagram. So this connection diagram we show that here is a 10 ohm, here is 5 ohm. So this connection like this here is neutral link. And this is the link, and we measure the 10 ohm and 5 ohm. And we measure the resistance. By this way, we can measure the polarity. So this is the across them with the ESR NZF 3017 rule. So every two side must be the switch on is 10 ohm, switch on infinity. Active to neutral, switch on is 15 ohm, or is infinity. Neutral to I, switch on is 5 ohm, switch on is 5 ohm. This is the way we have to connection. And this is the connection of the final circuit. Final circuit circuit main switch and also sub main, and this is the connection of the light and the socket outlet. This is the final circuit. So here is a connection of final circuits a predicated connection. Look at the light and look at the switch method. This is the look at the switch method, look at the light method. So this is the look at the light final circuit, and this is the also the look at the switch final circuit diagram. So there are the different electrical installation. So they must not be in the same conduit, because sometimes we do the wire line and the telecommunication line. We cannot run the wire and the power in the telecom line in the same conduit. And high voltage and low voltage on the extra low voltage must not be in the same conduit. Low voltage cable must be the insulation. Vertical cable needed insulated for the high voltage level. And also the scattering and trunking system, they are functioning to use as an Anglo system. So we have to read the 3.9.8.4 of the AS 3000 rule. Also, electrical service and the gas and the water must be the nodes are proximity. So they must not be close together. All the electrical gas and water must be separated. So this is for the important aspect. So the underground service is that we have to read as a table 3.7. And then so this is for the underground requirement. All the underground telecommunication system, we have to run in the different conduit. So today's lesson is that I explain you about the energy reduction principle. In the meantime, I explain you about the maximum demand calculation, the determination of the maximum demand for the socket outlet, and also electric gas wire configuration system. Those are today's lessons. Then we are talking about the electrical engineer workshop like this. Page 54. the next one is the physical and the psychological hazards in the workplace. The noise is defined as an unpleasant, unwanted. So this is the noise. So industrial noise are the machine noise, noise on the hand tool, noise on the transport, and also the different kind of the noise source. So the noise sources are producing the noise. So the dangerous noise are the blasting and explosive, and the heavy machineries are producing the noise. So we have to protect the noise. So the noise control method is the best one is the elimination method. We have to eliminate the noise and reduce the noise output. Also, containing means that we have to put the appropriate enclosure to contain the noise, and so that we use a personal protective equipment. So especially we have to utilize the ER plus to protect the noise. So this is for the how to protect the unpleasant noise in the work environment. So in this case, a certain noise space is 60 decibel. ER plus limit the noise level between 60 to 85 decibel. So vibration also problem because you are using the electric to power tool. Because of the vibration, your hand can be injured. Therefore, the workers need to utilize the appropriate regulation. We have to frequently expose to this noise level vibrations so they can suffer the permanent injury. So the vibration is in this case, the worker can suffer the itch in the arms and the shoulder. Also, the damage to the nerve system, vibrations of white finger in hand can happen. Also, the type of vibration, level of vibration, and the duration and frequency of vibration. They are the extent of vibrations that can damage the human body. And then in the meantime, we also need to be aware of the ultraviolet radiation system. Ultraviolet radiation is an invisible radiation rays. They are emitted from the sun to the energies are produced from the sun. So it's contained as a three-way length. So that especially the 400 millimeter to the 355 millimeter, 800 millimeter to 100 millimeter. Those are the ultraviolet radiation level. So we have to, though ultraviolet radiations are absorbed by the ozone layer, but at during the radiation time, especially the 12 known to the 2 p.m., this is the most of the sun rays are fall onto the earth. So therefore, the eye induced absorb 99% of the ultraviolet, so it can damage your eye. This is why you have to wear the appropriate sunglasses. So indoor radiation also can produce by the welding machine. So the welding machine produce the rays, so the rays need to be protected. So this is the important aspect. So another thing is that we have to utilize the ultraviolet radiation. There are two methods to reduce the ultraviolet radiation. First method is the appropriate engineering aspect. We have to use a shade cover. You have to utilize appropriate shade cover. Have to utilize to protect the ultraviolet radiation. In the meantime, administration, instead of allowing the worker to work outside, you have to allow the worker to do the inside activity. By this way, you can reduce the radiations absorbed by the worker. So another thing is the overuse syndrome. Overuse syndrome is that if you are using the too much, you are working for a very long time, you will be the injury can happen. Therefore, you have to be aware of not overuse yourself. So that we have to control the appropriate band. Work band need to be shoot at the appropriate level. Therefore, that you don't need to bend your back to do the job. Or handle need to be the ergonomically designed, also important aspect. In the meantime, you also have to utilize the appropriate personal protective equipment. Protective clothing, protective head cover, protective ER plus sunglasses need to be utilized. In the meantime, you have to reduce this work-related stress. If you are too much psychological stress because you are working on the deadline, so to meet your deadline requirement, you have to put the too much effort. So this is also you also suffer So that you self-discipline the stress relief programs are also important aspect. So stress can be the result of the doing the work. So most are jobs you have to meet the deadline limit. So sometimes you have to face the anxiety because of sometimes our workplace is a restructuring it happens, so you face anxiety. And also the different work condition. You are changing from the one job to another place, so that there will be the different work condition. You face with the environmental inspect or technology changes, they are also impact on you. So that those are the work related stress can suffer. In the meantime, competition, consumer demand, and also sometimes are your instruction given to use are unclear and very confusing. This also causing your stress. And also the personal protection equipment or the workplace relation problem, they are also impact on the person. Therefore, because of the workplace stress, you can suffer the frequent headache, feeling exhausted, also loss of the energy, change the appetite, and also sleep difficulty, and feeling the worn out, run down can happen. Therefore, you have to be the stress release programs are also important aspect. So this aspect is we are talking about the workplace environment and workplace protection. In the meantime, we have to talk about the sheet metal walls. I explain you about the sheet metal. Sheet metal walls are the electrical industry. You are using a sheet metal. We are forming a cable tray. We are using a cable duct, a trunking system. This is a sheet metal. So the sheet metal got the quality. They got the magnetic. They are got the toughness. They got the ductility, malleability, and also the hand hardness. Appropriate corrections are the system are sheet metal. So the kind of sheet metal materials are the mild steel. We use a mild steel for the straightforward casing, coating to prevent the corrosion, zinc annealing. Also the brass is also utilized for the electrical equipment. Now they are stronger and harder than the copper, not the magnetic resistant corrosion. Aluminiums are utilized for the electronic housing, and also they are hard to solder, and also the light, cheap, and the good conductor for electricity. Those are kind of the sheet metal being utilized. So that when you are using a sheet metal, are also the copper or the salt also easily can soldering and also good conductor for the both electricity and heat. And four brass are from that we use for the dark copper and also the stiffness backing, also the easier to bend. Silvers are the good conductor and straight contact and the low resistivity. And also that we utilize the silver, also the mono metal, and also the lithium copper, the electric sheet they are using, so that we have to use the appropriate sheet metal for the electrical contact, corrosive resistant, and the laminated magnetic core. So the sheet metal site are need to cross with the Austrian standard AS 1123 1972 edition. So this is the shape of the sheet metal. So the shape and the dimension of sheet metal. The sheet metal's thickness is a 0.3 to 3.2 millimeter or 3.2 to this is the sheet metal. So sheet metal can be cut by the test day. Test day are utilized to cut the sheet metal. And also for the last sheet metal, they are tips made are the 150 millimeter, 400 millimeters next we have to cut the thin of the sheet metal. Also we had to utilize the appropriate squeaking handles. Also the last sheet metal had to be cut by the guillotine machine. So we have to place the sheet metal onto the guillotine machine and we have to press the foot up, press, then you can cut the sheet metal. So in this case, those are the sheet metals are holding material. You use the pan, you have to utilize the hand washing, also the sheet metal bending, folding, and we can hold the sheet metal. So today's lesson is we are talking about the sheet metal and also the workplace environment. So this is for the electrical engineer, electrical trade 1 and electrical trade 2. In the meantime, we also have to look at the diploma aspect. So here is the electrical diploma. 2022.htm. Then you go down. Then you see the YouTube video electrical engineering lesson. Then click the lesson. Last week we have finished the circuit analysis E025. So today we utilize the power circuit analysis. So the mesh analysis lesson, you have to view this video, and also the source conversion, you view the video, also the Darwinian theorem, you can view this video, and node analysis, superposition, network analysis, and transient circuit. So those are the video you have to view. And also regarding the video lesson, you have to see the page 14 to page 25. So this is a video lesson. Page 14 to 45, this is video lesson. So another one is the denominator formula A1 I1 plus B2 I2 A1 B1 I1 plus B2 I2 M2. So that we can write down the denominator equation. I1 is equal to the denominator of the A1 M2 A2 B2 by, and denominator is the denominator of A1 B1 A2 B2. Similarly, I2 you can also calculate. I2 is equal to numerator is denominator of the A1 B1 A1 M2. Denominator is the denominator of the A1 B1 A2 B2. Okay, today let's transient in the capacity and internet market. So when you start supplying the electric voltage to the formula is that E by R multiply minus E power minus P by R. So the supply voltage is body volt and resistance side is A into 10 power 3 and E power minus A into 10 power 3 into 4 into 10 power minus 8. So the IC is the 5 into minus T E power 32 into the 10 power minus 3 milliampere. So this is for the example of the capacitance and the Ethernet circuit. So we call this transient circuit. Transient circuit means when the switch on the voltage and the current will flow to the capacitor and the voltage and current will increase, they follow the exponential graph. Okay, this is for the reflection and the transmission line. When the electric signal is sent from the source to load, so they are passing through the line. So those signals are usually reflected from the load. So the here is from the source, the voltage is sent to the load. So this one will be reflected. So this is the first reflection, and then the second that is descend the voltage and also the reflected. So some of the voltages are the passing through the load and some are reflected. So this is what the reflection and transmission line. So that we can calculate first reflection at the load is equal to V total is equal to V1 positive plus V1 negative. V1 positive means this is for the sending voltage. Sending voltage can be calculated. The formula is Vs multiplied Z0 by Z0 plus Zs. So in this case, Va is a source voltage, Z0 is a line impedance, and Za is a source impedance. So Z0 by Z0 plus Za is this is for the reflection coefficient. In the meantime, V1 negative. So this is a reflected voltage. So reflected voltage can be calculated. So this reflected voltage can be calculated as V1 negative multiplied tau L. Tau A is Za minus Z0 divided by Za plus Z0. Za is a low impedance. Z0 is a line impedance. So tau A is a reflection coefficient. So the reflected voltage can be calculated as sending voltage multiplied reflection coefficient tau L. So this is for the first reflection at the load. So total voltage at the first reflection at the load can be calculated. Vt is equal to V1 positive plus V1 negative. In the meantime, the second reflection at the source can also be calculated. So this is for the after the voltage is reflected from the load, they also reflected at the source. So the formula is a V1 positive plus V1 negative plus a V2 positive. So V2 positive is the second sending voltage to the load. So seconds after the reflection, the voltage are sent back to the load. So this V1 positive can calculate it. The formula is V1 negative multiplied tau S. Tau A is Zs minus Z0 divided by Zf plus Z0. Za is the source impedance, Z0 is line impedance. So this is the tau A is a reflection coefficient for the source. And then the voltage is reflected at the load. So this is the third reflection. Third reflection can be calculated. Vt is equal to V1 positive plus V1 negative plus V2 positive plus V2 negative. V2 negative is the reflection, second reflection voltage can be calculated. V1 positive tau L. Tau A is Za minus Z0 divided by Zf plus Z0. So those are the calculations of mesh analysis and also a source conversion method. So those are some of these example lesson. So you have to look at the those example and also you have to view the video. So those are the lessons. Those lessons are you see the power circuit analysis, mesh analysis, source conversion, also the Darwinian theorem, northern analysis, superposition theorem, AC network analysis, and transient circuit. So those are video. Those video you can view the video here. They are the circuit analysis of video. You can view it. And regarding the those video, we also see this written notes. Written note is that you have to follow this link. review.highlightcomputer.com/video lesson.html PDF. Then you look at the page number. Page number 350. This is a circuit analysis. You can see that here source analysis, source conversion, mesh analysis method. Here is circuit analysis, source conversion, mesh analysis. Also, how to utilize the determinant to solve the equation, also Darwinian theorem, also equivalent circuit resistance, northern theorem. You can also say the northern analysis, and also the application of the determinant method, and also Darwinian theorem, northern superposition theorem. Also, you can see the AC circuit analysis, AC network theorem, and also those are the page of 350 to 362. So this is a video lesson. Video lesson that you can see the video lesson, circuit analysis, video lesson, math analysis, source conversion, also the Darwinian theorem, nodal analysis, superposition theorem, AC network analysis. So this is a video. Those video you have to see. And written notes, written notes for the those video you can look at from this link, www.highlightcomputer.com/videolesson.pdf. So when you click this link, you can see that this is a written note. So written note is a page 350 to page 362. Page 350 to 362 is contained the written resources and written note for the video. So you look at the video and also you read through the notes, then you can get this circuit analysis.